Welcome back, I'm Steve Spangler, and we're talking about the science of weather and some cool experiments that you can try to demonstrate weather phenomena. I'm standing in front of this white wall because I want you to see some great color mixing going on as we explore the science of convection, or the mixing of air. Now, to demonstrate this, I'm using some simple things. This is water. It's cold water over here and warm water, the warmest water I can get out of the tap over here. I've just colored it blue being cold and yellow being warm. Let's fill 2 bottles with the warm water and 2 bottles with the cold water. Let's take a playing card and put the playing card right on top like this and turn the whole thing upside down and put this on the top. The only thing that separates these two is the playing card. So when I pull it away, it will allow the 2 liquids to be able to touch. All right, watch this. Here we go. Let me pull it away. And if I have a steady hand, it stays right there. Look at the mixing that we get. The warm water is working its way up to the top, and the cold water that's more dense is working its way down here. This motion that you see here of the hot rising and the cold falling down is what we call convection. And these convection currents move air in the atmosphere. Now, we'll put the cold water on the bottom and the hot water on the top. The card separates the two until we pull it out and watch what happens. If you predicted that nothing would happen, you were absolutely correct. The cold remains on the bottom and the hot remains on the top. Why? Well, the cold water is more dense, those molecules closer together than the hot water. And how we relate it to weather is we look at the difference in the air, the hot air on the top and the cold air on the bottom. In the wintertime, it's common for the cold air to get trapped on the bottom closest to the earth with a warmer layer of air sitting on the top. And when that happens, you get stagnant air in the very middle. Here, take a look at this. Do you see the only area that is starting to even turn green where we're seeing mixing at all is right there between the 2 bottles. In many cities, this is called the brown cloud. All the pollution that's trapped down closest to the earth with automobiles and industry doesn't get circulated like it would over here with the convection currents, and so you get this brown cloud that hovers over the city, and that's not a good thing at all. You know, this is really important, and I've got another experiment. I think that you'll be able to see the brown cloud even better. Take a look at this cool box. It's actually a really narrow aquarium with a divider that separates 2 sides. Pretty tricky. All right, here's what we're gonna do. Instead of me deciding which one goes on the top and which one goes on the bottom, I'll take the warm water on this side, yellow, cold water on this side, pour them in exactly at the same time, and then when they're at the same level, we'll pull the divider and see what happens. Bingo, there it is. Look at this. Yellow on this side, blue on this side. Let's let the water make the decision as to what happens. Here we go, watch. And there it goes, look. Does that look awesome? Look at this. Notice how that blue works its way on the bottom. More dense molecules are closer together there with that cold, and it sits there on that bottom. So the cold stays on the bottom, and notice how that warmer layer, the yellow layer, stays right there on the very top. And now take a look at that center layer where the 2 have started to mix. If you're gonna study the brown cloud or look at that smog effect, you really get to see what happens when the colder air is trapped on the bottom with the warmer air on the top, and you get this layer represented by the green here, which is the brown cloud.